Hey everybody, so I'm here to ask a question, right? What if you were to add up a series of fractions together with the same base but up to a higher power, right? And what would the limit be? Well, as long as your value is over x because, well, reasons, the value should be equal to 1 over x minus 1. As you can tell, the 1 plus, if you were to use powers of 1 and actually put it up to a base, it would equal infinity. And then you also have 0 divided by 0, which is in this equation. So it's pretty left open that the question would say, yeah, try to go beyond 1, and would tell you that multiple times. But here is the overall equation that we're looking at, right? If you were to simplify this, you'd have to just say that the denominator would be x to the power of n, but the top part would actually be equal to this series over here, right? Because ultimately you'd multiply it by x to the power of n, but then it'd be a fraction, sort of. But yeah, it's okay. But basically, what if you drew a second infinite series? And you'll notice something about these two infinite series, right? This, if you were to put this 1 back by creating an equation like this, it would obviously equal x minus 1 because x to the power of n would still be here and all of them would negate each other. But if you were to just leave these as is, it would equal 2 to the power of x minus 1. So then you are left with two equations. So what if you subtract the first equation from the second equation, right? Great. You're close now. All you have to do is multiply everything by x. Awesome. What do you do after this? You simply put the n minus 1 to the other side, and then what do? Divide everything by x to the power minus 1. A is equal to that. So ultimately, this series is equal to that. So then, if this series is equal to that, all you really have to do now is just form the sequence and calculations. Now we could easily just add 1, and that would be, and so therefore it can never approach this point, right? So it can never approach this point. But if you notice, this will be like a half over 1 or a third over 1 or something like that. But basically, we can easily say maybe this is equation A, this is equation A, and we can easily see why this would actually equal 1 over x minus 1. And yeah, that is the proof.